Hello Math 6 students and also any pre-algebra students who have wanted to watch a video on measures of central tendency. This is Mr. Giomini. I wanted to kind of talk about today the difference between median and mean. Sometimes we always want to say, well, the average is the best number that is the number that best represents a set of data, or it's the most accurate reflection of that data set. So I've kind of generated some numbers here, and it's home runs by the Boston Red Sox for 2011-2012 season. It says which measure of central tendency, median or mean, we also call that the average, most accurately reflects this data set. So I have my numbers here. I need to calculate both the median. I need to figure out the median. Necessarily is not always typically a calculation for median. Sometimes there is, but I also need to calculate the mean. So first thing I do is I'm going to organize these numbers from least to greatest. So I will start with 0, and as I write my numbers down, I'll cross them down up here so I don't use them again. I have a 4. I have a 17, an 18, 19. I'm going to go down here. I have a 20. And if you like to put the numbers, I'm putting them horizontally. Some of you like to go vertically. That is fine. You use a strategy that works for you. 22. 27, and finally 32. Now what I want to do is I double check here. I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces of data in the set. Let's double check to make sure I have a 10 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I could have also gone 2, 4, 6, 8, and 10. Okay, so we want to figure out the median. Again, sometimes there is a calculation involved in the median, especially if there's two numbers in the middle. And I want to calculate, slide this over, the mean, or we want to call it the average. Okay, calculate the median, very simple. I'm going to put my numbers in order from least to greatest. I'm going to cross out until I find that number in the middle. So I'm going from low to high here. 17, 22, 18, 21. Oh, I have two numbers in the middle, 19 and 20. Now, many of you can automatically jump and say, oh, 19 and 20, halfway between 19 and 20 is 19 and a half. Some of us were still kind of unsure about how to do that. So if I have two numbers in the middle when trying to calculate or solve for the median, I could just take and add 20 plus 19. That gives me 39. And I'm just going to find this average for these two numbers. So I'll take 39 and I'm going to divide it by 2 because I added two numbers to get 39. So 39 divided by 2 equals 19 and a half. So my median is 19 and a half. So that means the average player in the Red Sox last year hit 19 and a half home runs. Doesn't sound bad. Now let's calculate the mean, or the average. Now I'm going to pull my calculator out once again. I'm going to add all these numbers up together. 0 plus 4, that's easy. I don't have to put the 0 in my calculator. That's 4 plus 17 plus 18 plus 19 plus 20 plus 21 plus 22 plus 27 plus 32. Now, what's nice about this calculator equals 180. Now, I could take a look. There's 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces of data in my calculator. Enter. Let's see. I have 1, 2, 3, 4, 5, 6, 7, 8. 9. Oh, I have 10. Oh, that's right. I forgot to include the 0 because I really don't need to. Now, my average or my mean is not 180, obviously. I would now need to divide that by how many pieces of data are in the data set, which there are 10. So I go 180 divided by 10. That equals 18. Now the question becomes, these numbers are very close to each other. Which number most accurately reflects this set of data? They're about 1.5 off. Now, if I take a look, my lowest number is a 0, my highest number is 32. And it's kind of nice to look at these because I have an arrange in order from least to greatest. What I noticed though, the 0 and the 4, they're very small in comparison to the rest of the data set. So what they do, they don't affect my median because I'm just crossing out from front to back and finding that middle value. But they do affect my mean because as I add all these up, they're actually pulling this whole sum down. They're making the whole sum smaller. So 0 and 4 are what we call outliers. And outliers are those, that number or numbers, that kind of lay on the outside of the rest of the data, that are kind of far away from the rest of the data. Now I know you may say, well, Mr. Giamini, 17 is far from 32. You're right, but generally though, this is pretty darn near close to 20, and I don't think we say 20 is too far from 32. So this 0 and the 4, when I add those in to the whole data, it actually pulls the data set down. It shrinks it. It makes it smaller. So a more accurate reflection of this data set would be the median. And I always think about it this way. How many batters hit more than or equal to 18 home runs? And it would be less than or equal to, my fault. How many batters hit less than or equal to 18 home runs? We have 1, 2, 3, 4 out of 10. Now, how many batters hit about, we're going to go 19 and a half, so I'll go 19 or more home runs? We have 1, 2, 3, 4, 5, 6. 6 is a larger portion of this data set than the 18. So sometimes, you kind of, especially with determining which most accurate reflects this data set, as you begin to work with more numbers and calculate more means and averages and figure out medians, you'll get a better taste and a better feel for this. But hopefully this video helps you. All right, have a great night. Bye.